Hello everyone, this is kit number 5 and number 8, ROBOSIX. And this video is our reflection on what we learned in our Robotics 2 class this semester. Throughout the course, we worked with different components like the Servo Motor, Ultrasonic Sensor, and I2C LCD, and used them to build simple automated systems. In this video, we'll talk about how each component works, how they function together, the challenges we experienced, and what this class taught us. It's not just about robotics, but also about problem solving and learning through hands-on work.
So for our technical understanding of each of the component that we use for this SEM, first is the servo motor. The servo motor is a type of motor that is designed to move to specific angles instead of spinning continuously like a regular DC motor. Most of the time, it moves between 0 and 180 degrees, which makes it useful for controlled and precise movements. Working with angle control changed how we viewed movements in robotics. Instead of just turning something on and off, we had to think about how far something should move and why that angle mattered. And one challenge we encountered was jittering and incorrect positioning, especially when the power supply or timing wasn't stable. We figured it out by checking the wiring, adjusting delays in the code, and testing the servo separately to make sure it was working properly. Second is the ultrasonic sensor. The ultrasonic sensor measures distances by sending out sound waves and then calculating how long it takes for the echo to return. Using this sensor helped us understand how robots can detect objects without touching them. In practice, the sensor was mostly reliable, but its accuracy depended on factors like the distance of the object and the surface it was hitting. Even with these limitations, it played a big role in making the system interactive since it allowed the robot to respond automatically when something was nearby. Lastly is the I2C LCD. The I2C LCD was used to display information such as distance values and system messages. Feedback like this is important because it lets users know what the system is doing in real time. Using I2C communication made the setup much easier because it reduced the number of wires needed. The LCD also helped a lot during debugging since we could instantly see sensor readings and confirm whether the system was really working correctly.
The activity that stood out for us that involves integration of two or more components. The first was the interactive button LCD display that involves the integration of button when pressed. The LCD will display button press for 1 second before clearing the message. The next one is the potentiometer, controlled servo motor, that show us how to control the position of a servo motor using a potentiometer. Third, the automatic parking system, which combines an ultrasonic sensor with 3 different color LEDs that lights up red if the distance is close, yellow if it is near, and green if it's still far. Combine all these components, I think we can make a version of a modern secret vault using the ultrasonic sensor to trigger a ready state only when a user is within a specific proximity. Once in a range, the LCD I2C display a target value the user must match by rotating the potentiometer, acting as a digital combination dial. Pressing the button then validates if the dial is correct, triggering the servo motor to physically unlatch the lock. The LCD confirms access granted. The system combines a distance-based logic, log precision, tuning, and tactical confirmation into a single cohesive security interface.
Two of the most challenging activities that took us a lot of time to troubleshoot was first the light sensor reading display, where we struggled to make the light readings accurate, so we had to ask our teacher for help, and he figured out that we were missing a resistor, which didn't make sense for us that time because a light sensor is a photoresistor. Why would a resistor need a resistor? But at least that's a great aha moment, and that we got to learn that that's just really how things work. The second one was the potentiometer controlled servo motor, wherein nothing seemed to work. The first thing we did was to check the wiring and it looked okay. So we figured out to just ask our teacher for another servo motor, which turns out that the first motor was actually broken, and when we swapped it, everything finally worked. Our advice for all future students is to first always make it a habit to double check the wiring before powering up, as a single misplaced jumper wire is usually the culprit behind a broken If your LCD I2C is only showing blank boxes, don't be stressed. Just need to ask Sensei for a small screwdriver and gently adjust the blue screw on the back until the text appears. When it comes to servo motors, they can be a bit temperamental. If yours isn't moving, despite correct wiring, save yourself the frustration and swap it out for a replacement. See if the hardware itself is faulty. Staying patient with these small hardware fixes is just part of the process. These quick fixes will get your project running in no time. #good patience, #good grades.
After 2 semesters of working with my groupmates, our teamwork improved by being open to criticism and being more proactive whenever working with each other. There weren't many changes in our workflow, but our pace in doing activities became faster since our group became more helpful and took more initiative. Comparing our experiences this semester to last semester, we were able to change a lot of our attitudes, especially being more understanding and patient since we were able to get along, know each other, adapt others' way of learning and think. Our mindset also changed from trying to do everything faster to taking our time so that all of us could learn everything really well, which helped us actually to do things more effectively and quickly.
Overall, our biggest takeaways from this robotic class is that hands-on learning really helps deepen understanding. The challenges we face help us grow both technically and personally. This experience has prepared us to approach future projects with more confidence, curiosity, and patience we can ever have.